The next problem that we're going to look at is how do you get a VT graph? If you start with the velocity time graph, how do you figure out the other things? Okay, one thing that's important is you need to have an initial time or initial position, and then you need a chart. This is my calculating displacement chart, and so I say at 0 seconds we had an initial position of 10. Oops. And then the next section is 6 seconds later. 6 seconds later we were traveling during that time at 8 meters per second. So I'm going to use that other formula I talked about, the velocity multiplied by the time. So velocity was 8 meters per second. And for this section of time, it was from 0 to 6, so that's 6 seconds of this time. 8 times 6 is 48. So we've gone positive 48 from 10, so that puts us at 58. In the next section, that's going to be at 12 seconds. We were traveling during that time, according to this graph. If this is -4, this looks about halfway to it. So I'm going to say we're at -2 meters per second. And this is from 6 to 12. So the change in time, the delta t, is still 6 seconds on this part. So -2 times 6 gives me -12. So if I was at 58 and I go backwards 12, then it puts me at 46. The next section of time is only 3 seconds, because for these 3 seconds, we're going at 4 meters per second times 3 seconds. So that goes forward 12. So then we're back to 58. Next up, we're at 18 seconds. During this section, we have a velocity of -8 meters per second for 3 seconds. So that goes backwards 24. 58 minus 24 is going to be 34. Now I can go ahead and I can place in my time axis is messed up. This should be 3, 6, 9, 12, 15, and 18. We want to keep this the same as the graph below it, and then it should line up. So the first section, and we said it starts at 10. I'm going to start my axis at 0, and it looks like the highest I have is around 58, about 60. So if I count by 15s, I should be able to get my data into there. So 15, 30, 45, 60. So we started at 10, and then we went in 6 seconds, we went all the way up to 58, so just under that dot. And then the next 12 seconds, we went back down to just to 46, so just above the 45. I can put a dot there. Lost a dot. And then the next section, we went forward back up to 58. And in the last section, we go down to 34. And apparently my pen is messing up. So I'll just draw on roughly where the line goes. It goes, not at 10, it should start at 10. So we're going to go up to just about 60, down to around 46, up to 58, and then down to 34. Now obviously those should be straight lines. I'm having difficulty drawing on here, but you should be able to go through and calculate or set up that graph. For the mathematical model, I can say that x is equal to 8 meters per second times time plus the initial position of 10. That's the first section of time, and that was from 0 to 6 seconds. From 6 to 12 seconds, our velocity was -2 meters per second.
Jessica Hunter, if you're in the building, please call extension 4430.
And that was
Jessica
from
Hunter, please call
58.
4430.
That was from 58. The next section, x is equal to 4 meters per second times time plus 46. That was from 12 to 15 seconds. And the last section of time, x equals negative 8 meters per second times time plus 58, because that one started at 58. At 15 seconds, we were at 58. And that was from 15 seconds to 18 seconds. And so that's how you go through creating a mathematical model. That's starting with this graph. Another way to look at this graph is the area in here is going to be equal to displacement, because change in x is equal to velocity times time. Velocity on this graph is the height. Time is the base. So 8 times 6, that's going to be 48. Another way of looking at this, negative 2 times 6, that's negative 12. 4 times 3 gives me positive 12. Negative 8 times 3 gives me negative 24. So you can go through and set this up, and I like to shade these in, like I said, and then I can actually just write in how much it moves during those sections. So if it was at 10 and it went 48, we're at 58. Then from 58, we went backwards 12, forward 12, backward 24, which is what we have in that chart right there. And then you guys should be able to make the motion map. If you have questions, let me know. We're going to be working on more of these problems in the rest of the slideshow, and I will let you guys work on that, and I will see you in class, or I look forward to seeing you, hearing from you from my virtual students.